Welcome to the first of a two-part series of lectures talking about fractions. In this very first fractions lecture, we're going to look at what are fractions. We're going to talk about things like mixed numbers and improper fractions, equivalent fractions, how to reduce fractions. In this first lecture, we actually don't talk any about our functions. We're not going to talk about adding or subtracting or multiplying or dividing fractions. That comes in our second fractions lecture. This is just to lay the groundwork so that you are very well prepared to go into that second fractions lecture. First off, what on earth is a fraction? Well, there are a few different ways we can think about fractions. One way that I like to think of it is a part out of a whole, some part out of whatever you have total. So for example, let's say you're tired of having to cook for yourself and you order in a pizza, and your pizza comes cut only in 4 pieces because the pizza guy was lazy, and you eat 3 of those pizzas, or pieces of the pizza. You've eaten 3 pieces out of the 4 total pieces. Let's say that you tipped your driver $4.25. 25 cents can be represented as a fraction. 25 cents is 25 parts out of a whole 100 cents, and 100 cents make $1. So that's another way that we can think about fractions as a part out of a whole. There are different types of fractions that you'll see as you're working on your homework and going through the quizzes, and it's important that you are able to identify these quickly because there are some changes that you will have to do in your math dependent on what kind of fraction you're looking at. So our first kind of fraction that we have over here all the way on the left, this is a proper fraction. In here, the denominator is greater than the numerator. We saw denominator and numerator earlier in the decimals lecture. Just a reminder, denominator is your number on the bottom, numerator is your number on top. So a proper fraction is a denominator greater than the numerator. This is how a fraction is supposed to be written, ideally. That's why we call it proper. Second type of fraction you can see is an improper fraction. That's what we have here. In an improper fraction, our denominator is less than the numerator. So you see here our denominator is 3, our numerator is 4. An improper fraction is always greater than 1. We've taken a fraction and a whole number and just written the whole thing as a fraction. Now, the proper way to write an improper fraction is as a mixed number. A mixed number has both a whole number and a fraction. So 4/3 over here, 4/3 is the same as 1 1/3. And 1 1/3 is our expected way or proper way to write an improper fraction. Now, improper fractions are really, really useful. We use these for things like multiplying and division. You have to use improper fractions when you're doing that. But generally speaking, unless your homework says otherwise, all of your answers, all of your fractions should be written as proper fractions or mixed numbers. So if you are working on your homework and you get the answer 4/3 for your homework, you want to make sure that you convert it to 1 1/3 when you're done. And we'll look at how to do that a little later on. There are also some kind of generic fraction formulas that you should know just in general. I would work on committing these to memory. So if we use x for just any number, it could be 2, it could be 3, it could be 576. Any number x over 1 equals x. That's how you write a whole number as a fraction. So if I wanted to write 9 as a fraction, it would just be 9 over 1. X over itself equals 1. So if I have, say, 9 over 9, 9 over 9 is the same as 1. Think back to our pizza example. If you get a pizza that's cut into 9 slices and you eat all 9 slices, you have eaten the whole pizza. You're probably going to be terribly sick later tonight. The other thing that you should know is any 0 over x will always be 0. So again, if we're using x for 9, 0 over 9 is 0. You ate all 9 slices of the pizza. Your boyfriend got 0 of the slices of the pizza, or 0 out of 9. He's going to be hungry. You're going to be sick. Isn't quarantine life great? So know these formulas right here, especially these two. How do we write 1 as a fraction, and how do we write a whole number as a fraction? Those are going to serve you very well as we continue through fractions and beyond. So let's take a look at how we go back and forth between mixed numbers and improper fractions, and we'll look first at how do you convert a mixed number to an improper fraction. This is a technique that you want to be really solid in, because you will need this when you are multiplying and dividing fractions in the next lecture. You will also need this because your homework tells you in a bunch of questions to convert this mixed number to an improper fraction. So let's use, for example, 3 4/5. And 3 4/5, we can think about converting mixed numbers to improper fractions using a formula. We can think about this formulaically, where we substitute in our letters for our numbers. So A would represent our whole number, B represents our numerator, C represents our denominator. So 2 ways that we can think about this. And it uses your order of operations from earlier when we talked about that in the whole numbers. So nice to have that revisit. So first step for converting a mixed number to an improper fraction is to multiply your denominator and your whole number, where our denominator is 5, our whole number is 3. So 5 times 3 equals 15. Second step is to add your numerator to that answer. Well, we got 15, and our numerator is 4. So 15 plus 4 is 19. Last step, you're going to write that final answer over your original denominator. Well, we have 19, our denominator is 5, so 19 over 5. So that's 3 easy steps to think about this. If you prefer a formula, this is another way here to think about it, using this right here. So where A is our whole number, B is our numerator, C is our denominator, you would plug your numbers in respectively. So these 3 steps right here are just this in formula fashion. Step 1, multiply denominator and whole number. That's C times A. Step 2, add numerator. That's plus B. And then step 3, write your final answer over the original denominator. Well, that's our C down in the bottom. So you can see here, 5 times 3 plus 4, we substituted in our numbers for our letters, all over 5. 5 times 3 is 15, 15 plus 4 equals 19, 19 over 5. Just like that. Whichever way you like to think about this, if you like to think in the way of the 3 steps, or if you like to think in the way of the formula where you just plug your numbers in and go from there, either way is fine, as long as you're getting your right answer. I had one class that called it, that used what they said was the windmill technique. They would go in and do 5 times 3 and then add 4 and then write the answer over your denominator. Again, I don't care what technique you use as long as you are getting the correct answer. Let's look at a couple more examples. 5 3/7. Go ahead, pause the video, take a minute, see if you can figure this one out on your own, and then start it back up and we'll go over it together. So 5 3/7. Let's look at our 2 different ways. Remember A, B, and C. So 5 is A, 3 is B, 7 is C. So we would do, my class called this the CAB-C method. We do C times A, denominator times whole number, plus B, plus your numerator, all over C. So our denominator is 7. 7 times 5 plus the numerator 3, all over 7. 7 times 5 is 35, plus 3 over 7. 35 plus 3 is 38 over 7. You can also think about this, the 3 steps or the windmill technique. So first step would be whole number times denominator. So 5 times 7 is 35. Second step is add your answer to the numerator. So 35 plus 3 equals 38. And then last step is write your answer over the final denominator, 38 over 7. And either way, you get the correct answer. Make sure that you do not neglect that last step. I've had students who do that before, who do all of this multiplication and then say, here, your final answer is 38. But 38 is not equal to 5 3/7. If I owe you $38 and I give you $5 and a handful of change, that does not cover how much I owe you. So make sure that you are writing your answer over whatever denominator you started with, in this case, 7. Let's do one more example. Again, pause the video, take a minute, grab some scratch paper, and see if you can do this on your own. And then start the video back up, and we'll do it together. So 2 1/6. So if we do our little CABC method with our order of operations, this will be 6 times 2, denominator times whole number, plus your numerator, all over the denominator. So 6 times 2 is 12, plus 1 over 6. 12 plus 1 is 13 over 6. Or if you prefer thinking about your 3 steps, you would do step 1, 6 times 2, which equals 12. Step 2, 12 plus 1 to get 13. And then your last step, step 3, would be to write your answer over your denominator, 13 over 6. Either way, you should get the same answer. Okay, so we turned mixed numbers into improper fractions. Let's go the other way and turn an improper fraction into a mixed number. This is especially important because remember, all of your answers should be written as mixed numbers unless the homework specifically says write this number as an improper fraction. So to go from a mixed number to an improper fraction, we multiplied. Remember, we multiplied the denominator times the whole number. Here, because we're going backwards from an improper fraction to a mixed number, we are going to divide. And hopefully that makes a little intuitive sense to you. If we multiply to go from a mixed number to an improper fraction, when we're going backwards, we're going to do the opposite of multiplication, which is division. So when we divide the numerator by the denominator. So denominator will always be on the outside, numerator will always be on the inside of our division box. So for an example, let's look at this guy right here, 14/3. This is what your division setup should be like. Denominator is 3 on the outside, numerator is 14 on the inside. And we're just going to divide this like we would a normal whole number. So how many times does 3 go into 14? 3 goes into 14 4 times. 4 times 3 is 12. Subtracting, get 2. Okay. If this was whole numbers, what would we do? We would write, okay, 14 remainder 2. Done. If this was decimals, what would we do? We would add a decimal, we'd add a 0, we'd bring it down and keep going. But because this is neither whole numbers nor decimals, we're done here with our actual division. Now we need to figure out, we have all of these numbers. We've got a 4 up here, we've got a 2 as a remainder here, we've got this guy, maybe we do something with him. So this is usually where a lot of my students kind of lose their mind and sort of panic with all of these numbers that they have left over. But the answer, how we actually write our final answer, is very, very simple. Our remainder down here, this guy, will become our new numerator. So we're going to write 2 as a numerator. Well, what about a denominator? What do we need for a denominator? What denominator did we start with? We started with a denominator of 3. We end with a denominator of 3. And then this 4 that we have up here, the answer to our division, this is simply our whole number. So that's how we're going to put our answer together. An answer on the top is the whole number. Remainder, we drag him up to become the numerator. And then we take a look at whatever denominator we had, and we make their denominator the bottom half of our fraction. Okay, let's look at another example, 19/4. Go ahead, just like the last ones, and pause the video, try this on your own, and then come back and we'll look at it together. So this is what your setup should look like. 19 divided by 4, denominator, remember, on the outside of your division box, numerator on the inside. So let's go ahead and divide. What is 19 divided by 4? Before we'll go into 19 4 times to get 16. It's as high as we can go without going over. Subtract 19 minus 16 is 3. Okay, 3 is our remainder. We have a 4 up here on the top. Where do we start? Labeling your numbers after you're done with your problem can be very helpful to help you make sure that you don't forget what is what. So our 4, our answer up here, remember, is our whole number. What about the 3? What is he? The remainder down here. Well, he becomes our numerator. Okay, so let's write him as a numerator. And then what denominator do we use? Well, what denominator did we start with? We started with a denominator of 4. So we're going to end with a denominator of 4. Right? We just drag him over to the end of our problem. And there you go. Our final answer is 4 3/4. 4 3/4 is the same as 19/4. And you should always be checking your problems to make sure that you actually got your math right. So go ahead and check this one really quick. 4 3/4, if we multiply and add, we should get 19/4. So 4 times 4 is 16. 16 plus 3 is 19. 19/4. Good, we got it. One more example, 29/6. Take a minute, try this one, and then let's do it together. So here's your division setup. This is what it should look like. 29 divided by 6. How many times does 6 go into 29? 6 will go into 29 4 times, and 4 times 6 is 24. Subtract and get 5. Okay. Again, label your stuff. Make sure you know which number is which. Your answer up here, this is your whole number. How about your remainder? What is he? Remainder becomes your numerator. So let's write him as our numerator. And your denominator. What denominator did we start with? We started with a denominator of 6. We're going to end with a denominator of 6. So our final answer is 4 5/6 equals 29/6. And again, you should be able to run this problem backwards. 4 times 6 is 24. 24 plus 5 is 29. So good. That's a sign that we got our answer right. So what exactly does this mean? That 4 3/4 is the same as 19/4, or any of our other problems. What do we mean when we're writing something as an improper fraction? What we're doing when we write something as an improper fraction is we're taking our whole number and dividing it into those equivalent fractions as well, and then counting up how many total fractions we have. For example, if we hearken back to the pizza example, let's say you're, I don't know, having a party with fewer than 10 people and everyone's maintaining good social distancing, and you order 5 pizzas, and all 5 pizzas come cut into fourths. How many fourths total of all of the pizzas do you have? where, well, you have 4 whole pizzas, and Jerry grabs a slice of pizza before you can count the last one. So you have one that only has 3 out of its 4. But if you count these 4 whole pizzas right here, how many quarters total do you have in 4 pizzas, or how many slices, if you will? Well, you have 16 slices total. And then if you add in that extra 3 minus the slice that Jerry's eating in the corner, you have 19 total slices that are all fourths of the pizza. So that's what we're getting at when we're converting a mixed number to an improper fraction. We're just seeing how many, if we were to take these whole numbers and break them up into fractions, how many pieces would we have if each of those whole numbers was broken into fractions? Okay, last topic. Let's talk about equivalent fractions and reducing fractions and why we even care. So we'll start by discussing equivalent fractions. What does the word equivalent mean? What root word do we see in equivalent? You hopefully see the same root word as the word equal. And equivalent means equal. An equivalent fraction is the same fraction expressed in a different format. And a good example here is this great big list of fractions that are all 1/2. We have 1/2, 2/4, 3/6, 5/10, 20/40, 100/20, but these are all half of something. If you have, for example, $200 and I take 100 of them, I have taken half of your money. Or let's say you went out to the store and bought 10 apples and then you came home and your roommate ate 5 of them. Your roommate ate half of your apples. So all of these fractions are talking about the same idea or the same concept. They're talking about half of something, but we're writing them in different numbers depending on what we need. Now we can convert back and forth between equivalent fractions. It's very easy to go from, say, 1/2 to 20/40. It's just a matter of whether or not you're going to multiply or divide when you're going back and forth between equivalent fractions. If you're going from a fraction that has a smaller denominator to a bigger denominator, you're going to multiply. And this is a place where knowing your multiplication table will be very, very helpful. If you do not know your multiplication table, I do have a multiplication table posted in Blackboard at the very top of course content. Print it out, have it at your disposal. It's a wonderful tool to have while you're working through math class. So for example, let's look at 2/3. Let's say we want to write an equivalent fraction to 2/3, but with a denominator of 12. What is the same as 2/3 but written as 12ths? Well, we're going from a smaller denominator, 3, to a bigger denominator, 12. So we're going to multiply. Okay, 3 times what equals 12? Well, 3 times 4 will give us 12. But because we're doing this with a fraction, and this is a good rule to always remember whenever we're dealing with fractions, whatever you do to the bottom of the fraction, you also have to do to the top. So if we multiplied our denominator by 4, we're also going to multiply our numerator by 4. So 3 times 4 is 12, 2 times 4 is 8. So 2/3 is an equivalent fraction to 8/12. They are both 2/3 of something. Just with 8/12, we have slightly bigger numbers. And look at the number that we multiplied by. We multiplied 2/3 by 4/4. What is 4/4? What is any number over itself? Talked about this on slide 3. 4/4 is 1. We multiplied 2/3 times 1. And any number multiplied by 1 is itself, right? 2 times 1 is 2, 7 times 1 is 7, 13 times 1 is 13. So 2/3 times 1, we didn't change the value of our number when we got 8/12 as our answer. We just changed the size of the numbers by which we wrote it, the same as going from 1/2 to 5/10. Right? We did not change the value of our fraction here. We still have half of something, we just have half with slightly bigger numbers. Now, if you're going the other way, from a number with a large denominator to a number with a smaller denominator, you're going to divide instead. So for example, we have 55/66 here, and we want to write that as a fraction that has a denominator of 6. We want something smaller and a little less unwieldy. Well, 66 divided by what equals 6? Well, 66 divided by 11 will give us 6. So again, if we divide the bottom of our fraction by 11, we also need to divide the top of our fraction by 11. So 55/66 divided by 11 will give us 5/6. Let's look at two more examples. So here on the left, we see 5/6 equals what equivalent denominator or fraction with a denominator of 12. So 6 to 12, we're going from a smaller denominator to a greater denominator. So we're going to multiply, and 6 times what equals 12? Well, 6 times 2. So if we multiply 6 times 12, or 6 times 2 to get 12, we're also going to multiply the top by 2, which will give us 5 times 2 is 10. So 5/6 is equivalent to 10/12. How about this one? 56/84 to 12ths. Well, here we're going from a larger fraction, or a larger denominator, to a smaller denominator, so we're going to divide. Well, 84 divided by what equals 12? 84 divided by 7. So if we divide the bottom by 7, we also have to divide the top by 7. So 84 divided by 7 is 12. What is 56 divided by 7? That's 8. So 56/84 is the same as 8/12. So knowing equivalent fractions is important because equivalent fractions are what allow us to reduce a fraction. And probably you've heard of reducing fractions before, and if you're like most of my students, probably you want to throw up a little bit. But that's okay. We're going to take a look at it and go nice and slow. What is the point of reducing besides maybe making you sick? Why do we reduce fractions? Well, generally speaking, it's so we can talk about fractions in their simplest form. For example, if you have taken up stress baking during the pandemic and have been baking stuff and following recipes, you know that you're never going to see a recipe that tells you to add 3/6 of a cup of flour or add 4/8 of a cup of milk. But your recipe will tell you add half a cup of flour or add half a cup of milk. Similarly, you will never have a medical procedure in which you are instructed to give 3/12 of a gram of Ativan, but you may have to give a patient 1/4 of a gram of Ativan. So reducing allows us to talk about fractions in their simplest form. We do this by dividing. This is equivalent fractions, but only going one way. And when we're reducing, we want to find a factor that both our numerator and our denominator share in common, and we'll divide the numerator and denominator by that factor. What's a factor? This is a number that goes into another number. So for example, the factors of 6 are 1 and 6 and 2 and 3, because we can divide 6 by each of those. 6 divided by 1 is 6, 6 divided by 6 is 1, 6 divided by 2 is 3, 6 divided by 3 is 2. That's what we mean by factors. Now, don't confuse these with multiples, because the multiple for a number is essentially the times table for that number. So the multiples of 6 would be 6, 12, 18, 24, 30, 36, 42. We could keep going in theory. Factors are limited. You only have so many of them. In the case of 6, we only have 4 factors. Multiples are infinite. You have as many multiples as you want to hammer out on a calculator or write out by hand. So when we're reducing, again, we're looking for a factor, a number that goes into both of our numbers. That's not 1, because if you reduce by 1, you'll just get the same fraction again. So let's look at an example here. We have 24/38, and we want to reduce this down to a fraction that's a little smaller, not quite as unwieldy. So let's start by finding the factors of both of our numbers. For 24, what can we multiply to make 24? Well, 1 times 24, 2 times 12, 4 times 6, 3 times 8, all of these make 24. Okay, how about 38? We're a little more limited here. We know that 1 times 38 will make 38. 1 times any number is itself. 2 times 19, and that's about it. So where do we go? What do we put down for our common factor? Well, they share 1 in common, but remember, you don't want to use 1 as your factor because you'll just get the same number over again. How about 2? They share 2 in common. We could use that. So we're going to divide 24/38 by that factor that they share in common, by that 2. So we'll get 24/38. 24 divided by 2 equals 12. 38 divided by 2 equals 19. So 24/38 will reduce down to 12/19. Okay, how do we know if we're done? We have our 12/19 here. How do we know that we're finished? Well, there are 3 things that we look for, generally speaking, to know that we're done reducing. 1, and maybe the more difficult to determine, is we don't have any factors that are in common. So let's look at our factors real quick. For 12, what can multiply to make 12? We can do 1 times 12, 2 times 6, 3 times 4. How about 19? What are our factors of 19? 1, 19, that's about it. So we have no factors in common except for the 1, and you'll always have 1 in common. So that's a good indication that we're done. The other way that we know we're done is if our numerator is 1. For example, if you're reducing and you get 1/5, right? You can't reduce any further with a denominator that has 1. The other way, the third way that we know we're done, generally speaking, is if our denominator is prime. What on earth is a prime number? Is maybe a vocab word from the high school or middle school math that's sort of rising out of the depths of your memory. So a prime number can only be divisible or divided by 1 and itself. 19 is a prime number because 19 can only be divided by 1 and 19. Down here in our 1/5, 5 is also a prime number. 5 can only be divided by 1 and 5. So generally speaking, if you finish your reducing and your denominator is prime, you're probably done. Let's look at a few more examples. 42/66. Where to start, where to start, where to start? Well, looking at these 2 numbers, what's one thing that we notice about them right away? We notice that they're both even. They both end in even numbers. 2, 4, 6, 8, and 0 are even. Anything that ends in an even number is even, and that means we can divide by 2. So let's start there. 42/66 divided by 2, top and bottom. 42 divided by 2 will give us 21. 66 divided by 2 will give us 33. Okay, are we done? Take a minute, look on your times table, see if you can find 21 and 33 there and if they have any numbers in common. You should see 21 and 33 both have factors of 3. Both of these can be divided by 3 further. So 21 divided by 3 will give us 7. 33 divided by 3 will give us 11. Here we're done. 11 is prime, 7 is prime. There's nothing else that we can divide by to reduce them. So you'll notice in that problem, we did this 2 steps. We divided by 2 and then we divided by 3. And that is perfectly fine. If you want to start reducing with a small number like 2 or 3, instead of dividing the whole thing by 6, that's great. And sometimes you may have to start with a very small number like 2 in order to figure out what else might go in so that it's a little more obvious. How about that? 80/90ths. Goes into 80 and 90. How about 10? They're both multiples of 10. Let's divide top and bottom by 10. 80 divided by 10 is 8. 90 divided by 10 is 9. So 80 90ths will reduce down to 8 ninths. Let's see. Our numerator is not 1. Our denominator is not prime. Do they have any factors in common? 8, what can we multiply? 1, 8, 2, 4. How about 9? What can we multiply to make 9? 1 and 9. 3 times 3. So no factors in common, so we have reduced down as far as we can go for 80 over 90. How about 24 over 40? What goes into both 24 and 40? We can start with 4. They're both multiples of 4. 24 divided by 4 is 6. 40 divided by 4 is 10. So now we have 6 tenths. Is that done, or is there anything else that goes into both of those? Well, 6 and 10 are both even. We could divide both of those again by 2. So let's do that. Divided by 2, top and bottom. 6 divided by 2 is 3. 10 divided by 2 is 5. So 3/5. Can we reduce that down any further? Nope, because both of those are prime. One more, 50 75ths. What will go into both of those, 50 and 75? We could do 5. Let's do 5. Any number that ends in 5 or 0 can be divided by 5. So 50 divided by 5 is 10. How about 75 divided by 5? What will that be? That should give us 15. Okay, and then what? 10 and 15, we can divide by 5 again. 5 over 5 to get 10 divided by 5 is 2. 15 divided by 5 is 3. So 50 75ths is the same as 2/3. Again, we could have just taken this whole fraction, 50 over 75, and divided the whole thing by 25. And that would have been perfectly acceptable. And if you see that in a problem and you just want to go big and be done, that's great. We'll divide the whole thing by 25. But if you're not sure, start small. Okay, what about this, 4 and 4/6? Usually there's a lot of wailing and terror when we start pulling mixed numbers in to be reduced. But something to remember when you are reducing fractions is that you can't reduce a whole number. We cannot reduce 4. We can't write 4 using any smaller number than we have. So our whole number, when we're reducing a fraction with a whole number, the whole number, this guy right here, is a freeloader. He's that guy that's always sleeping on your brother's couch when you come over, doesn't work, plays video games all day, always asking you if you can take him to Walmart. The whole number in our mixed number here is a freeloader. We don't do anything with him. We just have to drag him to the end and make sure that he's there when we put our answer together and make it look pretty. The only thing that we can reduce here is our fraction. So let's reduce that. 4/6 can be divided by what? What goes into 4 and 6? How about 2? 4 divided by 2 will give us 2. 6 divided by 2 will give us 3. So 2/3. Our 4/6 will reduce down to 2/3. But what's our final answer? You gotta bring him. So our final answer is 4 and 2/3. How about this one? 2 and 36/6. Well, we can't reduce 2, so we'll take a look at 36 over 60. What goes into both of those? Those are both multiples of 6. So let's divide top and bottom by 6. 36 divided by 6 is 6. 60 divided by 6 is 10. Are we done? 6 over 10? Nope. We can divide one more time. Those are both even numbers, so they'll both divide by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. And then where's our freeloader? Probably playing video games on the computers at Walmart. We have to drag him along to the end. Don't forget your whole number. So our final answer is 2 3/5. So hopefully this has set you up very nicely to work on the homework for fractions part 1. Make sure that you pay careful attention to your formulas and your rules, because you will see all of this come back to visit you when you're working on your fractions part 2 homework that we'll go over on Thursday. As always, if you have any questions or want to double check your work, anything along those lines, swing by office hours or send me an email and we can look at it together.